Welcome back to Joint, Conditional, and the Two Laws That Run Everything, Part 5 of A. In Part 4, we built a conditional expectation of x given y and saw it is itself a random variable. Now we prove the first of our two great laws, the one that ties those conditional averages back to the overall average, the law of iterated expectations. It is the formal license for the single most common phrase in econometrics. Control for y. Here is the law in one sentence. The average of the conditional averages, weighted by how often each condition occurs, equals the overall average. In symbols, the expectation of x equals the expectation of x given y. It is sometimes called the tower property. So, you compute an overall average in two stages. First average within each group, then average those group averages, weighting each by how often it occurs. A school's average test score equals the enrollment weighted average of its classroom's averages. The law says these two roots always land on the same number. Splitting into groups and recombining loses nothing. Let us check it on Sam's numbers. Take the two conditional means from Part 4 and average them over the regime frequencies 0.70 and 0.30. The first term is 0.500. The second is minus 0.200. They sum to 0.30%, exactly the unconditional mean we computed the direct way. The two-stage root and the one-stage root agree to the penny. That is not a coincidence, it is a theorem. The proof is three honest lines. Start from the outer expectation, written as a sum over the values of y, each conditional mean times the probability of that regime. Substitute the definition of conditional expectation, the inner sum over x of x times the conditional probability. Now push the marginal of y inside. The product, conditional probability times marginal of y, is exactly the multiplication rule from Part 2, and it collapses to the joint. Sum the joint over y first, and that recovers the marginal of x. What is left is the sum over x of x times the marginal of x, which is just the expectation of x. Conditioning splits the sum into groups. Iterating expectations puts the groups back together. Why use this constantly? The law is the formal license for control for y. When you average within groups and then ask what it implies on average, the law guarantees you have not accidentally changed the overall mean. It is the engine behind regression's claim to estimate the conditional expectation, behind the no omitted variable bias arguments of week 2, and behind the causal logic of weeks 3 and 4. A surprising number of proofs in this book are: apply the law, then simplify. When does it fail? Essentially never, provided the expectation of x exists. For sufficiently heavy tail variables, the mean can be infinite, and then there is no finite number for the two routes to agree on. You will meet that pathology later with crypto returns. For any variable with a finite mean, the law holds with no further assumptions. To summarize Part 5, the law of iterated expectation says the expectation of x equals the expectation of the conditional expectation of x given y, average within groups, then average the group averages, and you recover the overall mean exactly. Both routes gave Sam 0.30%, and we proved it in three honest lines. This law is the backbone of every control for y argument and the engine behind regression. In Part 6, we turn from averages to risk and prove the second great law, the law of total variance.